welcome to this episode. Tonight, we begin a long, slow story about how the brain learned to sleep. Before we go anywhere, take a quiet moment to notice where you're tuning in from. What part of the world you're in right now, what the night feels like around you there. Maybe you're listening from a familiar room you've ended many days in before. Or maybe you're somewhere different, somewhere that feels slightly unfamiliar. Maybe it's late evening where you are, with the night just beginning to settle. Or maybe it's already deep into the night, when the world feels distant and quiet. You don't need to say anything out loud, just let the thought pass through gently. If you're listening at night, you can lie down or settle into whatever position feels most comfortable right now. There is nothing you need to prepare for, nothing you need to remember. This is a story meant to move slowly, at the same pace the night moves. Tonight, we are not starting with humans. We are not even starting with brains. We are starting before sleep existed at all. There was a time when nothing on earth slept. Not because life was restless, but because rest had not yet been shaped into what we now call sleep. The earliest forms of life lived in a constant present. They did not carry memories from one day to the next. They did not imagine what might happen later. They responded only to what was happening right then. Light appeared and they reacted. Darkness arrived and they changed. Warmth encouraged activity. Cold slowed it down. There was no inner experience of day or night, only chemistry responding to conditions. In this world, slowing down was not a choice. It was a consequence. If energy was available, life expanded. If energy was scarce, life contracted. This contraction was not sleep. It was simply survival. As the planet settled into more predictable rhythms, something subtle began to matter. Day and night became consistent. Light followed darkness. Darkness followed light. Over countless generations, life began to align itself with these cycles. Certain processes worked better in light. Others worked better in darkness. Cells adjusted their behavior depending on time. Repair happened when activity slowed. Growth happened when resources returned. Still, there was no awareness of rest, no internal signal that said it was time to stop. Rest happened because the environment demanded it. As life became more complex, movement entered the picture. Organisms no longer stayed in one place. They searched, they avoided, they escaped. Movement created new problems. If you move constantly, you burn energy quickly. If you stop moving at the wrong time, you become vulnerable. This tension shaped the earliest nervous systems. The first nervous systems did not exist to think. They existed to coordinate, to move toward what helped, to move away from what harmed. These systems learned to switch between states, active when conditions allowed, less active when conditions were dangerous. This switching is important. Before sleep existed, there were states. Not consciousness and unconsciousness, but engagement and withdrawal. Withdrawal did not mean the system shut down. It meant it reduced its interaction with the world. Over time, this reduction became more organized. Night played a central role. Darkness changed the rules. Vision became unreliable. Movement became risky. For many organisms, being still at night increased survival. Stillness conserved energy. Stillness reduced detection. Stillness allowed the body to focus inward. This is where the idea of sleep truly began to take shape. Not as a single moment, but as a gradual adaptation. The nervous system learned that there were times when interacting with the environment offered fewer benefits, and times when internal maintenance mattered more. At first, this maintenance was simple. Cells repaired damage, energy stores were replenished, basic balance was restored. As nervous systems grew more complex, something new appeared: memory. Memory changed everything. With memory, experience could be carried forward. Patterns could be recognized. Danger could be avoided more efficiently. But memory came with a cost. Information had to be processed, stored, integrated. Doing this while constantly responding to the environment was difficult. The nervous system discovered that processing worked better when input was reduced. Less noise, less movement, less demand. This reduction was the ancestor of sleep. The brain began to create a protected window, a time when external input mattered less, and internal organization mattered more. At first, this window was brief: light rest, easy to interrupt. Animals could not afford long periods of disconnection. The world was too unpredictable. So sleep evolved alongside safety. Shelter appeared: burrows, nests, places where the body could remain still without being exposed. As protection increased, rest could deepen. This is a pattern that repeats throughout evolution. The safer the organism during rest, the deeper the rest could become. As brains grew larger, this became even more important. Larger brains required more maintenance, more energy, more organization. Sleep expanded to meet those demands. Different depths of sleep began to emerge. Light sleep, deeper sleep. Periods where the brain became active internally while the body remained still. These internally active periods would later be recognized as dreaming. But at this stage, dreaming was not symbolic. It was functional. The brain replayed patterns, strengthened useful connections, weakened others. This process improved survival. Organisms that slept effectively adapted faster. They learned more efficiently. They responded more flexibly to change. Sleep was no longer just helpful. It was becoming essential. By the time mammals appeared, sleep had taken on a richer form. Mammalian brains were warm and energy-intensive. They processed emotion. They formed social bonds. These functions required careful regulation. Sleep became the time when that regulation happened. Mammals did not simply rest. They entered complex sleep cycles, cycles where the body relaxed deeply, and cycles where the brain became internally active. Dreaming emerged as a natural extension of this. Dreaming allowed emotional experiences to be processed without physical risk. It allowed learning to continue without exposure to danger. Sleep was now shaping not just the body, but the mind. As mammals evolved, social life became more complex. Caring for offspring, living in groups, maintaining relationships. These demands influenced sleep as well. Sleeping alone was risky. Sleeping together increased safety. Group sleep allowed deeper rest. This shift would later matter greatly for humans. But long before humans, sleep had already become a sophisticated biological process. The brain had learned how to alternate between attention and withdrawal, between engagement and restoration. Sleep was not an accident. It was refined over millions of years. This is why sleep feels natural when it works, and deeply uncomfortable when it does not. Your brain is not guessing how to sleep. It is following instructions older than thought. As you lie here now or continue listening, those instructions are still present. They respond to rhythm, to light, to stillness. They do not respond well to force. In the next part of this story, we will move forward in evolution, toward reptilian brains and early vigilance, toward creatures that learned how to remain still without losing awareness. But for now, it is enough to rest with this idea. Sleep did not begin as comfort. It began as survival. And because it was shaped so carefully, it still knows what to do. This story will continue. As this first part continues, we move a little closer to something familiar, not to humans yet, but toward the kind of brain that first had to solve a very difficult problem. How do you rest without fully disappearing from the world? As nervous systems grew more complex, simple withdrawal was no longer enough. Stillness alone could become dangerous. Some creatures needed to remain aware, even while inactive. They needed to notice vibration, changes in temperature, the approach of another living thing. This is where early vertebrate brains began to change the story of sleep. Instead of a full shutdown, the brain began experimenting with partial disengagement. Certain systems reduced activity. Others stayed watchful. This was not yet the sleep we recognize, but it was closer. The brainstem became increasingly important here. It maintained basic life functions without interruption. Breathing rhythms, heart regulation, internal balance. Above it, newer regions learned how to alternate between alertness and quiet. This layering mattered. The brain no longer had to choose between full engagement and full stillness. It could distribute responsibility. Some parts could rest, others could remain on guard. This was a major evolutionary advantage. Animals that could rest without becoming completely vulnerable survived longer. They conserved energy without sacrificing awareness. Over time, this balance became more refined. Sleep was no longer just about the absence of movement. It became about controlled disconnection. The brain learned to decide which signals mattered and which could be ignored. Sounds that were familiar faded. New sounds stood out. Touch became less sensitive, but sudden pressure still registered. This selective awareness is still with you today. When you sleep through background noise but wake to something unfamiliar, you are using an ancient system. As reptiles appeared, this pattern became clearer. Reptilian brains were efficient, focused on survival. They did not waste energy on unnecessary processing. Their sleep was simple but effective. Long periods of stillness, reduced responsiveness, quick return to alertness when needed. They did not dream as mammals do, but they rested in a way that protected essential systems. This kind of sleep favored vigilance over depth, and it worked. But evolution rarely stops at what works. As environments became more complex and social interaction increased, new pressures emerged. Emotion entered the picture. Memory became more layered. Learning became more than avoidance. It became adaptation. This is where mammals changed the rules again. Mammalian brains introduced warmth. Literally, warm-blooded animals needed constant energy regulation. Their brains ran hotter, more active, more sensitive. This created a new challenge. The brain could no longer rely on simple stillness for maintenance. It needed dedicated time to reorganize itself. Sleep deepened. Instead of remaining lightly vigilant, the mammalian brain learned how to temporarily trust its environment. This trust was not blind. It was conditional. Safe shelter, group protection, familiar surroundings. When those conditions were met, the brain allowed itself to go deeper. This is when sleep stages became more pronounced. Light sleep, where awareness flickers. Deeper sleep, where consciousness fades. And internally active phases, where the brain works without waking the body. Dreaming became a side effect of this internal work. Not because dreams were needed for meaning, but because meaning was being processed. The the mammalian brain had to manage emotion, attachment, fear, reward. These could not be fully resolved during waking life alone. Sleep became the space where emotional experiences could be revisited safely. This was revolutionary. A brain that could soften fear overnight had an advantage. A brain that could reorganize social memory without risk adapted better. This is where sleep began to shape personality. Not consciously, quietly. By the time early primates appeared, sleep was already complex. Primates slept in trees, in groups, balancing vulnerability with protection. They developed lighter sleep when exposed and deeper sleep when secure. This flexibility mattered. It allowed the brain to adjust rest based on context. The same brain could sleep differently depending on safety. That flexibility still exists in you. When you are in a familiar place, sleep comes easier. When you are somewhere new, it stays lighter. This is not anxiety. It is ancient logic. As primates evolved into early humans, the environment changed again. Fire appeared. Fire transformed the night. It pushed back darkness, reduced predators, extended social time. For the first time, humans could remain awake after sunset without immediate danger. This changed sleep profoundly. Sleep became more consolidated, more intentional. Humans did not sleep in short fragments anymore. They slept in longer blocks. Fire also introduced storytelling, reflection, shared memory. The brain began carrying more narrative. This increased the need for sleep even further. More memory, more emotion, more identity. Sleep adapted again. Dreams became richer, more symbolic, not because symbols were needed, but because the brain had more material to integrate. Language had entered the nervous system. This is an important moment in the story. Sleep evolved without language, but once language arrived, sleep had to handle it. Thoughts, plans, regrets, imagined futures, all of this needed sorting. Sleep did not change its purpose. It expanded its capacity. Modern humans still carry this ancient structure. Your brain does not sleep because you are tired. It sleeps because it has learned, over millions of years, that this is how it stays functional. When sleep is difficult, it is rarely because the brain has forgotten how. It is usually because the conditions it expects are not present. Too much stimulation, too much uncertainty, too much demand. The brain waits. Not stubbornly, patiently. It is listening for safety signals, darkness, stillness, predictability. When those signals appear, systems older than thought begin to take over. That is why understanding sleep often helps more than forcing it. Understanding removes conflict, and conflict is what keeps the brain alert. As this first part comes to a close, there is nothing you need to remember. No lesson to hold. Only this quiet idea. Sleep is not something humans invented. It is something humans inherited. It was shaped long before you existed, long before your worries, your plans, your thoughts. And it still works the same way. In the next part, we will move deeper into the reptilian brain and early vigilance, into how the brain learned to stay still without losing awareness. For now, you can let this part settle. Whether you keep listening or drift away, the story continues quietly, just as the brain always has. As we continue, there is no need to shift your attention in any particular way. This part of the story moves deeper into time, into a kind of brain that had to learn a very delicate balance. How to rest without becoming defenseless. After the earliest nervous systems learned to slow down with night and rhythm, a new challenge emerged. Life was no longer simple and still. Creatures were moving through complex environments. Some hunted, some were hunted. In this world, complete shutdown was dangerous. This is where the reptilian brain enters the story. Early vertebrates developed brains that were efficient, practical, and focused almost entirely on survival. These brains did not reflect on the past or imagine the future. They monitored the present. Movement, vibration, temperature, threat. The reptilian brain was not built for comfort. It was built for readiness. Sleep, in this context, could not look like surrender. It had to look like controlled stillness. Instead of disappearing from the world, these brains learned to reduce activity while keeping essential sensing systems active. This was a major shift. The brainstem became the anchor. It maintained breathing, circulation, and balance without interruption. Above it, primitive sensory systems learned how to quiet themselves selectively. Not everything faded, only what was safe to ignore. This is where light sleep was born. Light sleep is not weakness, it is strategy. In reptiles, sleep often appeared as long periods of immobility. The body remained still. Muscle tone dropped slightly, but awareness never fully vanished. At any moment, the animal could return to full alertness. This rapid transition was crucial. Predators do not wait politely. Neither does danger. So the reptilian brain learned how to hover near wakefulness. This kind of sleep conserved energy while preserving reaction speed. It did not involve dreams. There was no inner narrative to process, but there was maintenance. Cells repaired themselves. Energy was redistributed. Basic balance was restored, all without the brain ever fully letting go. This is why reptilian sleep appears fragmented and shallow compared to mammalian sleep, but it was exactly what that stage of evolution required. As environments became more competitive, reptiles refined this strategy further. Some learned to sleep in safe locations. Others developed camouflage that allowed deeper stillness. The safer the context, the longer the stillness could last. But even in safety, vigilance remained close. The reptilian brain never forgot that the world could change instantly. This ancient logic still lives in you. When you sleep lightly in a new place, when you wake easily to unfamiliar sounds, you are not failing to rest. You are using a system that evolved to keep you alive. The reptilian brain does not ask whether you are tired. It asks whether you are safe. This distinction matters. As evolution continued, brains became larger and more layered. But the reptilian foundation was never removed. It remains underneath everything else. Even in humans, parts of the brain still operate by these rules. They monitor the environment continuously. They decide whether deeper rest is allowed. When they detect uncertainty, they keep sleep shallow. This is not anxiety. It is ancient caution. Over time, some reptiles developed slightly more complex sleep patterns, short bursts of deeper stillness, moments where responsiveness dropped further. But these moments were brief. The brain tested depth cautiously. Evolution rarely jumps. It inches forward. The key achievement of the reptilian brain was not deep sleep. It was controlled rest, a state where the body could recover, while the brain remained close enough to the surface to react instantly. This balance shaped everything that followed. When mammals later appeared, they inherited this system. They did not discard it. They built on top of it. That inheritance explains many things about human sleep. Why part of the brain always seems awake. Why complete unconsciousness is rare. Why we can wake suddenly when something feels wrong. the reptilian brain never sleeps deeply. It stands guard. As this part of the story settles, it may be useful to notice something. Even now, as you lie still or continue listening, some part of your brain is monitoring the room. It notices changes without effort. It listens without attention. That part does not need instructions. It has been doing this for hundreds of millions of years. And because it does its job so reliably, other parts of the brain are allowed to rest. In the next part of this story, we will see how mammals changed the rules again, how emotion entered sleep, how memory began to reshape the night, and how dreaming quietly appeared. For now, it is enough to recognize this layer. Sleep did not start as depth. It started as vigilance softened by stillness. And that ancient balance is still part of every night you experience. Over time, this balance between rest and readiness became deeply embedded in the nervous system. It did not disappear when brains grew larger. It became the foundation everything else relied on. As environments shifted and species diversified, some creatures began to live in ways that slightly reduced constant exposure to danger. Burrows became deeper. Shelter became more reliable. Certain habitats offered predictability. In these conditions, the brain was able to experiment, not with surrender, but with trust. The reptilian brain did not suddenly allow deep sleep. It tested it carefully. Moments of reduced vigilance appeared. Short at first, easily reversed. The brain learned that if nothing bad happened during these moments, it could try again and stay a little longer. This learning happened over thousands of generations, not within a single lifetime. Each generation inherited a slightly more refined ability to rest. Still, the reptilian brain never stopped listening. Even when activity dropped, sensory systems remained partially active. Certain signals were still prioritized. Movement close by, changes in pressure, sudden shifts in sound or temperature. These signals could pull the brain back to alertness instantly. This instant reversal became a defining feature. The ability to wake quickly was as important as the ability to rest. From an evolutionary perspective, this made sense. Deep sleep without the ability to wake would have been fatal, so the brain learned to maintain a thread of awareness at all times. This thread is subtle. It does not involve conscious thought. It does not require attention. It simply exists. As you listen now, even if your thoughts drift or your awareness softens, that thread remains. It is not something you need to manage. It manages itself. As evolution continued, some species began showing signs of something new. Not full dreaming, but internal neural activity that did not directly respond to the environment. The brain was beginning to turn inward. This inward activity was limited at first, brief, fragmented, but it hinted at what was coming. The reptilian brain had solved the problem of resting without disappearing. That solution created space for deeper processes to evolve. Once safety could be maintained during stillness, the brain could afford to do more than simply conserve energy. It could reorganize. This reorganization required time. Time without constant interruption. The reptilian system provided the first version of that time. Stillness with vigilance. As mammals emerged, this stillness would deepen. But even then, the reptilian foundation remained in place. In humans, it still does. This is why some nights feel lighter than others. Why sleep can feel shallow when conditions are unfamiliar. Why the brain seems to hover near the surface in new environments. The reptilian brain is checking. It is not anxious. It is cautious. Understanding this changes how we relate to sleep. Light sleep is not failure. It is context-sensitive rest. The brain is adjusting depth based on perceived safety. This adjustment happens automatically. Trying to force deeper sleep often increases alertness because effort signals uncertainty. The reptilian brain responds to signals, not instructions. Darkness, quiet, stillness, familiarity. These are the signals it understands. As this layer of the story settles, the arc of evolution continues forward. The reptilian brain has done its work. It has created a platform where rest is possible without danger. On top of this platform, a new kind of brain will appear. One that brings emotion into the night, memory into rest, and meaning into dreams. That next step will transform sleep again, not by replacing vigilance, but by learning when it can finally be shared. The story continues, slowly, in the same direction the night always moves. As the story continues forward through time, the environment changes again. Bodies become warmer. Movement becomes more fluid. Social bonds begin to matter in new ways. This is where mammals enter the picture. Mammalian brains did not abandon the reptilian foundation. They inherited it fully, but they added something that would quietly transform sleep forever. Emotion. With emotion came attachment. With attachment came vulnerability. And with vulnerability came a new problem for the brain to solve. How do you rest deeply when losing awareness could mean losing those you depend on? Mammalian life required more than vigilance. It required bonding, caring for offspring, recognizing familiar individuals, responding to subtle social cues. These demands increased the brain's complexity. They also increased its need for internal organization. Emotion is powerful, but it is also costly. Fear, curiosity, comfort, distress. All of these states activate the brain intensely. They cannot remain unresolved indefinitely. The mammalian brain needed a place to process feeling without action. Sleep became that place. At first, this processing was cautious. Mammals still slept lightly compared to humans. They woke often. They remained responsive. But something new appeared during rest, periods where the body remained still, yet the brain became active in a different way. Neural patterns began replaying. Experiences from waking life resurfaced, not as direct memory, but as fragments. Emotion guided what was replayed. Important experiences returned first. Fearful encounters, moments of connection, events that mattered for survival or bonding. This replay was not conscious. It was internal work. The mammalian brain was learning how to soften emotion, how to integrate memory, how to prepare for the next day without constant rehearsal while awake. Dreaming was beginning to take shape. Not as stories yet, not as symbols, but as emotional processing. During these internally active states, the brain looked awake. Electrical activity increased. Patterns resembled waking consciousness, but the body remained still. This separation was crucial. It allowed the brain to explore experience without risking movement in the real world. Evolution had found a way to think safely. As mammals diversified, this ability deepened. Species that lived in safer environments developed longer periods of internal activity during sleep. Species that faced constant threat kept these periods brief. Sleep adapted to context. This flexibility became one of the mammalian brain's strengths. Emotion, once a constant driver of behavior, now had a quiet place to settle. Fear could be revisited without panic. Attachment could be reinforced without action. Learning could continue without exposure. Sleep became more than rest. It became regulation. This is why mammals deprived of sleep show emotional instability. Without sleep, feelings remain sharp. Responses become exaggerated. The brain loses its ability to soften experience. Even early mammals carried this pattern. They slept in short cycles. They dreamed briefly. They woke often. But each generation refined the process. As social complexity increased, sleep became more valuable. Living in groups increased safety. Safety allowed deeper rest. Deeper rest allowed more emotional processing. This created a feedback loop. Social bonds supported sleep. Sleep supported social bonds. This loop would eventually define human life. But long before humans, the mammalian brain had already learned something profound. Rest was no longer just about survival. It was about emotional balance. As you lie here now, or continue listening, this ancient system is still active. The part of your brain that feels emotion relies on sleep to reset itself. When nights are short or restless, emotions feel closer to the surface. When sleep is deep, feelings soften naturally. This is not psychological theory. It is evolutionary memory. Your brain learned long ago that the night is where emotion belongs. As mammals evolved further, memory and emotion became more intertwined. Experiences were no longer stored as facts alone. They were stored with feeling. Sleep had to manage both. Dreaming became richer. Fragments combined. Faces blended. Places shifted. Not to confuse the mind, but to reorganize it. Meaning was being shaped quietly. This process would continue, becoming more refined as brains grew larger. The stage was now set for something unprecedented. A brain that could reflect on itself. A brain that could remember its past and imagine its future. A brain that would sit by fire and tell stories into the night. But that story comes later. For now, the mammalian brain has changed sleep forever. It has turned the night into a place where feeling can rest, where memory can soften, where the mind can prepare for tomorrow without knowing that it is doing so. The story continues, moving gently forward, toward the moment when sleep would begin to carry identity itself. As evolution moves forward, the brain grows not just larger, but quieter in a new way. Not quieter in activity, but quieter in how it holds awareness. Early humans inherited everything that came before. The vigilance of reptiles, the emotional depth of mammals, the flexible sleep shaped by safety and threat. But something changed when humans began to shape their nights instead of simply reacting to them. Fire altered darkness. For the first time, night was no longer absolute. Shadows could be pushed back. Predators kept their distance. Warmth lingered after the sun disappeared. This single change reshaped sleep. Before fire, night meant vulnerability. After fire, night became shared time. Humans gathered. They stayed awake longer. They spoke. They listened. Language settled into the dark. This mattered deeply for the brain. Language increased memory load. Stories carried lessons. Names carried identity. The past could be recalled deliberately. The future could be imagined together. The brain now had far more material to organize. Sleep adapted again. Human sleep became more consolidated. Longer stretches of rest replaced fragmented stillness. Dreaming became more elaborate. Not because dreams were meant to predict or warn, but because the brain now carried complex narratives that needed integration. The night became the place where stories were rearranged. Dreams reflected this. Scenes shifted quickly. Characters blended. Emotions lingered even when details faded. This was not randomness, it was compression. The brain was learning how to reduce rich experience into something usable. As humans formed stronger social bonds, sleep took on another role. It protected identity. When you live among others, your sense of self is constantly shaped by interaction. Sleep became the time when that sense of self could be stabilized. Experiences were replayed privately. Conflicts softened. Connections were reinforced. This is why social stress affects sleep so strongly. The brain recognizes unresolved interaction as unfinished work. Sleep tries to complete it. As human environments became more stable, sleep deepened further. Shelter improved. Communities formed. Threat became less constant. The brain allowed itself to let go more completely, but it never fully released vigilance. The ancient systems remained. Even today, some part of your brain stays alert. It listens for change. It checks for safety. This is not a flaw. It is inheritance. Modern life complicates this inheritance. Artificial light extends day into night. Noise replaces silence. Information continues without pause. The brain receives mixed signals. It is told it is night, but shown constant activity. It tries to reconcile this. Sometimes it struggles. When sleep feels difficult, it is often because the brain is receiving contradictory messages. Evolution prepared the brain for darkness, stillness, and predictability. It did not prepare it for constant stimulation. Understanding this reframes sleep difficulty. The brain is not broken. It is cautious. It is waiting for conditions it recognizes. When those conditions appear, systems older than thought begin to take over. Breathing slows. Muscles relax. Attention loosens. The mind drifts not because it is told to, but because it is allowed to. As this long story continues, it approaches the present moment. The brain you are using now is ancient, layered, patient. It learned to sleep before humans existed. It refined sleep as humans changed the world. And it still uses the same logic tonight. Sleep is not an escape from awareness. It is a shift in responsibility. Older systems take the lead. Newer systems rest. This handover is quiet. It does not announce itself. You may notice thoughts fading, images appearing, time becoming less defined. These are signs of a process that has been unfolding for millions of years. The story does not end here. It continues every night, not as history, but as experience. And whether you remain awake listening or drift gently away, your brain will continue doing what it has always known how to do. Slowly, carefully, through the night. As the story reaches closer to the present, something subtle becomes clear. The brain did not evolve sleep for a single reason. It layered reasons on top of one another. Survival first, then safety, then emotion, then memory, then identity. Each layer remained. This is why sleep feels different depending on what the brain is carrying. On some nights, the body feels heavy, and sleep arrives quickly. On others, the body rests, but the mind stays active. On others still, sleep is deep, but filled with vivid dreams. These are not different kinds of failure. They are different modes of the same ancient system. The human brain is not trying to turn off. It is trying to redistribute work. During the day, newer parts of the brain dominate. Planning, language, decision-making, self-monitoring. At night, these systems slowly hand responsibility back to older ones. This handover does not happen all at once. First, attention loosens. Then logic becomes less strict. Then time loses its structure. Finally, awareness thins. This sequence mirrors evolution. The newest systems step back first. The oldest remain the longest. This is why you may feel drowsy but still alert. Why thoughts feel softer before they disappear. Why dreams feel ancient and familiar, even when strange. Dreams are not messages sent by the brain. They are echoes of how the brain learned to think before language, images before sentences, feelings before explanations, movement before meaning. When the brain dreams, it is speaking an older language, one it learned long before words. This is why dreams often resist interpretation. They are not meant to be translated. They are meant to resolve. The brain uses dreams to release tension, to reorganize memory, to soften emotion. It does not need your attention to do this. It only needs time and relative safety. This brings the story to something important. Sleep is not fragile, but it is sensitive. It responds to cues: light, sound, predictability. When these cues align with what the brain expects, sleep unfolds naturally. When they conflict, the brain hesitates. This hesitation is not resistance. It is caution, the same caution that once kept reptiles alive in the dark, the same caution that allowed mammals to care for their young, the same caution that let early humans sleep near fire without fear. Your brain is still making the same calculations. Is this environment stable? Is this moment predictable? Is it safe to let go a little more? When the answer is yes, sleep deepens. When the answer is unclear, sleep stays light. Understanding this changes how we approach the night. Instead of asking how to force sleep, we can ask how to signal safety, not through effort, but through consistency. Familiar sounds, gentle light, repeated routines. These are not habits. They are evolutionary signals. They tell the brain that nothing unexpected is about to happen. When the brain believes that, it does the rest on its own. This is why sleep advice that focuses only on control often fails. Control is a waking strategy. Sleep responds better to permission. Permission is given through environment, not through thought. As the night continues, the brain shifts again. If sleep deepens, awareness fades. If dreams appear, the brain is integrating experience. If waking returns briefly, the brain is checking its surroundings. All of this is normal. All of it is part of the same process. The brain did not evolve to sleep perfectly every night. It evolved to sleep adaptively. Some nights required vigilance. Others allowed depth. Modern life often demands consistency that evolution never promised. The brain still expects variation. Some nights light, some nights deep, some nights filled with images, some nights empty. This variation is not disorder, it is flexibility. As this story continues toward its later chapters, we will look at how modern humans live with ancient sleep systems. Why understanding sleep often helps more than optimizing it, and why, despite all changes, the brain still returns to the same rhythm. For now, it is enough to notice this. Sleep is not something you do. It is something that happens when the brain recognizes familiar patterns. And those patterns are older than worry, older than effort, older than thought. They have been guiding the night for millions of years. And they are still here, quietly, doing their work. As evolution continued, the brain began to solve a problem that no single organism could solve alone. Safety. For millions of years, rest depended almost entirely on individual vigilance. If danger appeared, the individual had to detect it. If a mistake was made, there was no backup. But as some species began living closer together, something changed. Safety could be shared. Sleeping in proximity meant that no single brain had to remain fully alert all the time. Attention could be distributed across many individuals, one brain listening while another rested more deeply. This was a quiet revolution. Group living did not remove danger, but it diluted it. Predators were less likely to approach a cluster. Movement from one individual could alert others. Sound traveled through the group. The brain noticed this. Over time, nervous systems adapted to the presence of others during rest. This adaptation was not social in the modern sense. It was biological. The brain began to register proximity as protection. This changed sleep. When surrounded by familiar bodies, sleep deepened. When alone, it remained lighter. This pattern appears across many species. Animals that sleep alone rarely enter long, deep states. Animals that sleep in groups often do. The brain learned that safety was not just environmental, it was relational. This realization reshaped the night. Instead of constant individual vigilance, early mammals began to alternate. Some slept lightly. Some slept more deeply. The group, as a whole, remained aware. This allowed something new: extended rest, longer periods of reduced responsiveness, longer periods of internal processing. Sleep cycles became more stable. The brain could afford to let go for longer stretches, knowing that it was not alone. This social buffering had powerful effects. Emotion regulated more effectively. Memory integrated more thoroughly. Stress responses softened. Sleep became more restorative. As primates evolved, this effect intensified. Primates slept close together. They groomed. They formed bonds. These bonds mattered at night. The brain began associating familiar individuals with safety. Their presence lowered vigilance. This is why separation affects sleep so strongly. The brain notices absence as potential risk. Even today, humans experience this. Sleeping next to someone trusted often feels different. Sleep comes easier. It feels deeper. This is not just comfort. It is evolutionary memory. The brain learned long ago that shared rest increased survival. As early humans appeared, this pattern continued. Humans slept in groups. Families gathered. Communities formed. Night was no longer faced alone. Fire added another layer of safety, but people mattered just as much. The sound of breathing nearby, the subtle movements of others, the predictable presence of familiar bodies, these became signals the brain trusted. They allowed sleep to deepen further. This is where human sleep became uniquely social. The brain did not simply check for predators. It checked for belonging. Belonging signaled safety. Without belonging, vigilance increased. This explains why isolation can make sleep feel restless, why unfamiliar environments keep the mind alert, why loneliness affects the night so strongly. The brain evolved to rest together, not constantly awake together, but together enough that vigilance could be shared. This shared vigilance freed something important: time. Time for deeper sleep, time for longer dreams, time for emotional processing. The night became longer on the inside. This social structure also shaped how the brain handled fear. Fear no longer had to be resolved alone. The presence of others softened it. This allowed the brain to process emotion more effectively during sleep. Stress that lingered during the day could settle at night, because the brain no longer felt solely responsible for survival. This is one reason why reassurance helps sleep more than reasoning. The brain listens to signals of safety, not arguments. As societies grew more complex, these signals became subtle. Tone of voice, routine, familiar sounds. The brain learned to recognize these as signs that nothing unexpected was about to happen. When those signs were present, sleep deepened. As this part of the story unfolds, it reveals something important. Sleep was never just a biological process. It was always social. The brain did not evolve to rest alone in silence. It evolved to rest within a web of familiarity. Even now, the brain responds to this. A familiar voice, a steady presence, a predictable environment. These cues tell ancient systems that vigilance can ease. As the story continues, we will move further into human sleep, into how identity, memory, and meaning became woven into the night. But for now, this layer matters. Sleep deepened not only because the world became safer, but because others made it so. And the brain remembered. As these social patterns stabilized, the brain began to rely on them more deeply. Safety was no longer assessed only through sight or sound. It was sensed through presence. The nervous system learned to recognize familiar rhythms, breathing nearby, subtle shifts of movement, the quiet reassurance of others resting at the same time. These rhythms mattered. They became part of the brain's calculation about whether it could let go further. When many bodies settled together, the environment felt predictable. Predictability allowed vigilance to soften. This softness did not mean absence. It meant redistribution. Some awareness stayed at the surface, but much of it moved inward. This allowed sleep to deepen in ways that had not been possible before. Longer stretches of reduced responsiveness appeared. Dreaming extended. Memory integration became richer. The brain used this opportunity fully. Emotional experiences were revisited more thoroughly. Social interactions were reorganized. Conflicts softened without conscious effort. The night became a place where relationships were quietly processed. This processing was not deliberate. The brain did not analyze social life. It absorbed it. Faces appeared in dreams. Voices echoed. Scenes replayed and dissolved. These were not messages. They were adjustments. The brain was tuning itself to live among others more effectively. This tuning mattered. Humans who slept well within groups were more emotionally regulated. They responded more flexibly during the day. They maintained bonds more easily. Sleep and social life reinforced each other. Over generations, this reinforcement shaped human nights. Sleeping alone became unusual. Sleeping together became the norm. The brain adapted accordingly. It began to expect certain cues at night, sounds of life settling, shared routines, predictable rhythms. When these cues were absent, the brain noticed. Not consciously, biologically. Vigilance increased. Sleep became lighter. This is why unfamiliar environments disrupt sleep so reliably. The brain is not confused. It is cautious. It is waiting for signals it recognizes. As human societies grew more complex, these signals changed form. Firelight replaced moonlight. Shelter replaced open ground. Walls replaced proximity, but the underlying expectation remained. The brain still looked for familiarity, for continuity, for signs that the night would unfold as expected. This expectation explains many modern sleep experiences. Why silence can feel unsettling instead of calming. Why certain sounds are soothing even if they are not quiet. Why routine matters more than comfort. The brain is not seeking perfection. It is seeking predictability. Predictability signals safety. Safety allows depth. This is the thread that runs through every stage of sleep evolution. From stillness in darkness to vigilance softened by rest, to emotion processed through dreams, to identity stabilized within social bonds. Each layer builds on the one beneath it. None replace what came before. This is why sleep feels layered. Some nights feel physical, some emotional, some reflective. The brain is not malfunctioning on those nights. It is addressing different needs. Social safety allows the deepest needs to surface. When social connection is strained, sleep often becomes shallow. The brain returns to vigilance. This does not mean something is wrong. It means the brain is prioritizing survival. Understanding this changes the relationship with sleep. Instead of trying to remove wakefulness, we can focus on restoring safety signals. Familiarity, routine, gentle presence. These are not luxuries. They are evolutionary tools. As this part of the story settles, the arc continues forward. The brain has learned how to rest deeply when others are near. It has learned how to share vigilance. It has learned how to use the night to maintain emotional balance within a group. The next transformation will build on this. The night will become a place not just for regulation, but for meaning. Memory will begin to shape identity. Dreams will begin to reflect the self. The brain will start asking quieter questions. Who am I among others? What has happened? What might come next? That story unfolds next. As the night carries us further forward, as human life became more settled, the night changed again. Not in a dramatic way, but in a way that slowly altered how the brain related to itself. Earlier, sleep had been shaped mostly by survival and safety. Now it began to be shaped by meaning. Humans did not just live together, they remembered together. They shared stories. They carried histories that extended beyond a single lifetime. This changed the mind. Memory was no longer only about danger or reward. It became about identity. Who you were was shaped by what you remembered. And what you remembered was shaped by who you lived with. The brain now carried layers of experience that were not immediately useful for survival, but deeply important for belonging. Sleep adapted to this. During the day, humans gathered information constantly. Faces, voices, rules, expectations. The brain learned how to navigate social life, but it could not fully process it while awake. Too much depended on immediate response. Sleep became the place where social experience could be reorganized, not logically, emotionally. At night, the brain revisited interactions, not in full detail, but in fragments. A tone of voice, a feeling of tension, a moment of connection. These fragments did not appear to teach lessons. They appeared to soften edges. The brain was learning how to remain part of a group without carrying constant emotional weight. This is where dreams began to change. Dreams were no longer just emotional processing. They began to include the self. You were in them. You moved through scenes. You reacted. This was new. The brain was experimenting with identity. During waking life, identity had to be stable, predictable, consistent. At night, it could be flexible. Dreams allowed the brain to explore variations of the self, different responses, different roles, not consciously, quietly. This flexibility helped humans adapt socially. It reduced rigidity. It softened conflict. It allowed the brain to update its sense of who it was. Sleep became a place where identity could be adjusted without risk. Firelight played a role here. Evening gatherings extended wakefulness. Stories were told. Experiences were shared. The brain received rich social input right before rest. This input did not disappear at night. It followed the brain into sleep. Dreams absorbed it. This is why human dreams often involve people, conversations, and social situations. The brain evolved to process these experiences at night. As language became more complex, this effect deepened. Words allowed humans to describe feelings, to name experiences, to reflect on events, but language also increased cognitive load. Thoughts multiplied. Plans extended further into the future. Regret and anticipation became possible. The brain now had to manage not just experience, but interpretation. Sleep adapted again. Dreams became more narrative. Scenes connected loosely. Time shifted. The brain was compressing meaning. This compression allowed waking life to remain functional. Without it, thoughts would accumulate endlessly. Sleep became the mind's way of clearing space. As societies grew larger, identity became more layered. A person was not just an individual. They were part of a family, a group, a culture. The brain carried many roles. Sleep helped reconcile them. At night, roles loosened. The self could move freely. This freedom was not escape. It was maintenance. By morning, identity returned, but with edges smoothed. This is why sleep affects how you feel about yourself. Not because it changes facts, but because it changes emotional weight. The brain learned that the night was the safest time to reorganize the self. This learning became deeply ingrained. Even now, when you sleep, the brain revisits who you are. What matters? What can be released? You may not remember this process, but you feel its result. Some mornings feel lighter, others heavier. This reflects what the brain processed at night. As this transformation took hold, sleep became inseparable from meaning. The night was no longer just about restoring the body or regulating emotion. It was about maintaining continuity of self. This is why sleep deprivation affects identity so strongly. Without sleep, the self feels unstable. The brain loses its quiet place to integrate experience. Understanding this helps reframe the night. Sleep is not passive. It is not empty. It is active work done without awareness. Work that keeps the self coherent. As the story continues, we will move closer to the modern mind, to a brain that thinks constantly, plans endlessly, and struggles to rest in a world that never fully goes dark. That challenge, and how the brain responds to it, comes next. As this sense of self became more complex, the brain faced a new kind of pressure. The mind could now think beyond the present moment. It could imagine outcomes. It could replay the past in detail. It could worry about things that had not yet happened. This ability was powerful. It allowed planning, cooperation, and long-term survival. But it also meant the mind rarely rested on its own. Thoughts did not stop when the body stopped moving. They continued into the night. Sleep had to adapt once more. The brain began learning how to quiet its newest abilities, not by shutting them down completely, but by loosening their grip. At night, logical sequencing weakened. Strict timelines dissolved. Cause and effect became less rigid. This was not a loss of control. It was intentional softening. The brain was creating space. By reducing the dominance of structured thinking, older systems were allowed to work. Emotion could be processed without judgment. Memory could be reorganized without analysis. The sense of self could bend without breaking. This is why night thinking feels different from day thinking. Thoughts may still appear, but they feel less sharp, less demanding. The brain is not trying to solve problems at night. It is trying to integrate experience. When modern humans struggle to sleep, it is often because this softening does not happen easily. Artificial light keeps the brain alert. Continuous information keeps planning systems active. Unresolved demands keep the mind oriented toward the future. The brain senses activity and stays engaged. This is not because it refuses to sleep. It is because it is doing what it evolved to do. It stays ready when the world seems active. Understanding this changes the approach to sleep. Instead of asking the brain to stop thinking, it is often more helpful to allow thinking to lose structure. This happens naturally when stimulation decreases, when input becomes predictable, when nothing new is demanded. The brain then shifts modes on its own. As this shift happens, identity becomes less fixed. The self loosens. You may notice this as drifting, as moments where thoughts feel distant, as a sense of being present without effort. This is the brain stepping back from its most recent layers. Evolutionarily, this is expected. The newest systems always step back first. They are the most flexible, the least essential for immediate survival. Older systems remain. Breathing continues. Balance is maintained. The body stays regulated. This layered handoff allows sleep to deepen. In modern life, this handoff is often interrupted. Notifications arrive. Lights remain on. Schedules extend late into the night. The brain receives mixed signals. It tries to rest, but it is reminded to stay alert. This tension explains much of modern insomnia. The brain is not broken. It is conflicted. It is waiting for a clear signal that the day is truly over. When that signal arrives, the transition happens naturally. Thoughts lose urgency. Images appear, time stretches, sleep unfolds. This unfolding is not something you control. It is something you allow. The brain has been practicing this transition for thousands of generations. It knows how to do it. As this part of the story settles, it brings us close to the present moment. A modern brain carrying ancient systems, living in a world that rarely goes quiet. The next part of the story will explore this directly. How modern environments challenge ancient sleep mechanisms, and why understanding this tension is often the first step toward rest. For now, the night continues to do its quiet work. And whether you remain aware or drift gently away, your brain is following a path it has walked many times before. The modern world introduces a situation the brain has never fully faced before. Not danger in the traditional sense, but constant stimulation without resolution. For most of human history, night brought a clear shift. Light faded, activity slowed, sound diminished. These changes told the brain something important, that nothing new was expected for a while, that the environment had settled. Modern life blurs this signal. Light remains bright long after sunset. Voices travel through walls and devices. Information continues without pause. The brain notices this, not as stress in the emotional sense, but as uncertainty. Uncertainty keeps ancient systems alert. The brain asks the same questions it always has. Is the environment predictable? Is it safe to disengage? Is anything about to happen? When the answers are unclear, sleep remains shallow. This is not a malfunction. It is an ancient response meeting a new context. The brain evolved in a world where night meant stillness. It did not evolve for endless input. This mismatch explains much of modern difficulty with sleep. The brain is being asked to rest while signals of activity continue. It tries to adapt. Sometimes it succeeds. Sometimes it remains near the surface. This is why modern sleep often feels fragile. Not because the brain has forgotten how to sleep, but because the cues it relies on are diluted. Understanding this changes how we interpret wakefulness at night. Wakefulness does not always mean the brain is failing to sleep. Sometimes it means the brain is waiting for clarity. Clarity does not come from force. It comes from consistency, repeated patterns, familiar routines, predictable transitions. These are modern equivalents of ancient signals. They tell the brain that the environment is stable, even if light and sound persist. When the brain receives these signals consistently, it adapts. Sleep becomes easier not because effort increased, but because uncertainty decreased. Another modern challenge appears here. The mind now carries information far beyond immediate experience. News from distant places, social interaction without physical presence, concerns that have no clear boundary. The brain evolved to process information that ended at night. Modern information does not. This keeps cognitive systems active. Sleep asks those systems to step back, but they hesitate when input continues. This hesitation often appears as mental activity. Thoughts that surface when the body rests, images that replay, plans that feel urgent. The brain is not trying to disturb sleep. It is trying to complete unfinished processing. In earlier times, the day ended clearly. Work stopped. Conversation slowed. The mind followed. Now, the day can stretch indefinitely. Sleep must negotiate its place. The brain adapts by becoming more sensitive to subtle cues. Tone of light, sound quality, familiar sequences. These cues help it decide whether to transition. This is why small changes can have large effects on sleep. A consistent routine, a familiar sound, a predictable ending to the day. These signals tell ancient systems that the modern world is quiet enough. As this part of the story unfolds, a pattern becomes clear. Sleep is not a switch. It is a negotiation between ancient biology and current conditions. When conditions are unclear, the brain waits. When conditions align, sleep unfolds on its own. This negotiation happens every night, quietly, without awareness. The brain does not judge the outcome, it adjusts. Some nights require more vigilance. Others allow depth. This flexibility is not a weakness. It is resilience. As the story continues, we will explore how this negotiation plays out inside the brain itself, how different systems take turns leading, and how rest emerges when control loosens naturally. The night continues, and the brain continues its careful listening. As the brain continues this negotiation, it relies on something subtle but powerful: prediction. From its earliest days, the nervous system learned to survive by anticipating what would happen next. Not consciously, but biologically, patterns became safety. When events followed familiar sequences, the brain relaxed. When sequences broke, vigilance returned. This is still how the brain approaches the night. Sleep unfolds more easily when the evening follows a familiar shape. Not because the brain enjoys routine, but because routine reduces uncertainty. Uncertainty keeps systems alert. Predictability allows them to step back. This is why the brain responds so strongly to small inconsistencies at night. A sudden sound, an unexpected message, a light turning on. These are not distractions in the casual sense. They are signals that the environment may still require attention. The brain responds accordingly. It does not argue with the signal. It simply adjusts depth. This adjustment is fast, often faster than conscious awareness. That is why a brief interruption can change the entire texture of the night. Once vigilance increases, the brain does not immediately return to rest. It reassesses. Is this change temporary? Is it meaningful? Is it likely to happen again? Only when the environment settles consistently does sleep deepen again. This is not stubbornness. It is calibration. The brain is continuously matching its internal state to the world around it. In modern life, this calibration can become difficult. The world rarely settles completely. Notifications may arrive at any moment. Lights stay on. Sounds fluctuate. The brain adapts by staying partially ready. This partial readiness is often experienced as light sleep, or as repeated waking, or as a sense that sleep never fully takes hold. Understanding this reframes the experience. The brain is not resisting rest. It is staying responsive. When responsiveness is no longer needed, rest follows. This is why sleep often arrives suddenly after a period of wakefulness. Not gradually, but all at once. The brain waits, then releases. This release feels like slipping. Thoughts lose structure, images blur, time stretches. This moment is not created by effort. It is permitted by stability. When the brain feels confident that nothing urgent will appear, it lets go. This letting go is ancient. It is the same process that allowed early mammals to dream safely. That allowed humans to sleep near one another. That allowed identity to soften at night. Modern conditions do not erase this process. They obscure it. When the signals become clear again, the process resumes. This clarity can come from very simple things: lowering light, reducing variation in sound, ending interaction predictably. These actions do not force sleep. They remove ambiguity. The brain responds by stepping back. Another important aspect of this negotiation is trust. The brain trusts patterns more than intentions. Wanting to sleep does not signal safety. Consistent conditions do. This is why trying to control sleep often has the opposite effect. Control implies uncertainty. Uncertainty keeps systems active. Letting conditions speak for themselves is more effective. The brain listens constantly. It weighs signals. It decides when to shift states. This decision happens below awareness. By the time you notice sleep approaching, the decision has already been made. This is why sleep advice that focuses only on mindset often falls short. The brain is not convinced by reassurance alone. It responds to experience. Experience tells it whether the night is predictable. As this part of the story settles, it highlights something reassuring. Sleep is not lost. It is adaptive. Even in a world that never fully quiets, the brain continues to look for opportunities to rest. It may take longer. It may come in fragments, but it still arrives. Because the systems that guide it were shaped over millions of nights, they are patient. They do not demand perfection, only enough stability to let go. As the night continues, and as this story moves forward, the brain keeps listening. And when the moment feels right, it does what it has always done. It rests. As the night deepens, something subtle begins to change, not in the world outside, but in the way the brain relates to it. Awareness does not disappear all at once. It thins. At first, attention loosens its grip on specific details. Sounds blend together. Edges soften. The mind stops tracking time precisely. This thinning follows an ancient pattern. The newest layers of the brain, the ones responsible for constant monitoring and interpretation, begin to step back. They do not shut down. They simply stop insisting on control. The brain has learned that there is a moment when control is no longer useful. During the day, awareness is sharp because it needs to be. Decisions matter. Responses matter. Timing matters. At night, those demands fade. The brain recognizes this shift not through logic, but through rhythm. Light decreases. Movement slows. Input becomes repetitive. These signals tell the brain that immediate action is unlikely to be required. When this recognition happens, awareness changes its role. Instead of directing, it observes. Instead of focusing, it drifts. Thoughts may still appear, but they feel less anchored. They come without urgency. They leave without resolution. This is not distraction. It is transition. Evolution prepared the brain for this gradual fading. A sudden loss of awareness would have been dangerous, but a slow thinning allowed flexibility. If something important happened, awareness could return quickly. If nothing happened, it could continue to soften. This balance is still active. As awareness thins, the sense of self begins to loosen as well. Not disappear, but become less defined. You may notice this as moments where you forget what you were thinking about, or where you lose track of how long something has lasted. Time becomes less structured because the brain no longer needs it to be. This is not a loss. It is relief. The brain is releasing a tool it no longer needs for now. As this happens, older systems take over. Breathing becomes more regular without effort. Muscle tone decreases. The body settles into stillness. These changes are not commanded, they are allowed. The brain has learned that when awareness thins safely, the body can rest more deeply. Images may begin to appear. Not full dreams yet, just impressions, colors, faces, fragments of places. These images are not messages, they are byproducts. They appear as the brain shifts from processing the external world to processing itself. Memory systems become more active, but they are no longer constrained by logic. Fragments combine freely. Emotion guides what surfaces. This is the doorway between waking and sleep. It is a state humans have entered every night for thousands of generations. The brain knows this space well. It does not rush through it. It moves at its own pace. Trying to observe this process too closely often brings awareness back, because observation is a waking skill. When awareness is allowed to drift, the transition continues. This drifting is not losing control. It is handing control to systems designed for rest. The brain has practiced this handoff countless times. Even if it feels unfamiliar, it is deeply learned. As awareness continues to thin, language becomes less dominant. Sentences lose structure. Words feel heavier to hold. This is because language is one of the newest tools the brain uses. It steps back early. What remains are sensations and feelings, warmth, heaviness, distance. These sensations signal that the body is settling. Evolutionarily, this made sense. Language was never needed to rest. The brain does not require explanation to sleep. As this part of the story unfolds, awareness may come and go. Moments of clarity followed by moments of absence. This fluctuation is normal. The brain is testing depth. Each time it returns to awareness and finds nothing demanding attention, it relaxes a little more. This gradual descent protects against danger while allowing rest. It is careful, not hesitant. The brain is not afraid of sleep. It respects uncertainty. When uncertainty fades, so does vigilance. As this happens, the boundary between inner and outer experience softens. Sounds may feel distant. The sense of body position may blur. This is not disorientation. It is disengagement. The brain is shifting priorities. Soon, awareness will no longer be central. It will still exist, but it will no longer direct experience. That transition leads into deeper states of rest, states where thought dissolves completely, where time disappears, where repair happens quietly. That deeper descent comes next. For now, it is enough to let awareness thin at its own pace. The brain knows how to do this. It always has. As awareness continues to soften, it begins to lose its center. There is no single point where it disappears. Instead, it spreads out, becoming less concentrated. Thought no longer feels like something you are doing. It feels like something that passes. This change is subtle, but important. During the day, awareness is organized around intention. You decide where to focus. You hold ideas in place. You guide attention deliberately. At night, that organization dissolves. Attention becomes passive. It no longer reaches outward. It no longer holds tightly. The brain recognizes that nothing requires immediate response. This recognition allows another shift. The sense of effort fades. Even listening begins to feel different. Sounds may still register, but they do not pull attention. They exist without demand. This is not tuning out. It is deprioritizing. The brain is still aware of the environment, but it no longer treats it as central. This is the point where many people feel they are still awake, yet no longer fully present. This in-between state is not unfinished sleep. It is a complete state on its own. Evolution built this state as a buffer, a place where the brain can reverse course instantly if needed, or continue downward if conditions remain stable. This is why drifting feels so natural. The brain is not falling asleep. It is allowing sleep to arrive. As awareness thins further, the sense of continuity weakens. Moments no longer connect smoothly. Gaps appear. You may not notice these gaps when they happen. You only notice that time feels uneven. This unevenness is a sign that awareness is no longer tracking experience continuously. Memory formation is changing. The brain is no longer storing events in sequence. It is letting them fade. This fading is intentional. There is no need to remember the transition into sleep. Remembering requires energy. The brain conserves energy by letting memory loosen. As this happens, the feeling of being a separate observer softens. You are still here, but the sense of watching yourself begins to dissolve. This is often experienced as heaviness or as a gentle distance from the body. The body does not disappear. It simply stops being monitored closely. Muscles relax further. Posture becomes irrelevant. The brain shifts control to systems that operate without awareness. Breathing continues steadily. Heart rhythm adjusts. Internal balance is maintained. These systems do not need attention. They are older than attention. This handoff marks a threshold. Beyond this point, awareness no longer guides the process. It becomes background. The brain is now free to enter deeper states. States where there are no thoughts to follow, no images to interpret, no sense of passing time. This depth is not empty. It is active in a different way. Repair begins here. Neural connections adjust. Metabolic waste is cleared. Energy is redistributed. None of this requires awareness. In fact, awareness would interfere. That is why it fades. This fading is not loss. It is protection. The brain protects its deeper work by keeping consciousness light and flexible. If something important happens, awareness can return. If nothing happens, it continues to recede. This balance has been refined over millions of nights. The brain does not rush it. It does not force it. It follows signals, stillness, predictability. absence of demand. When those signals remain consistent, the descent continues. Eventually, awareness becomes so diffuse that it no longer forms experience. There is no sense of inside or outside, no narrative, no observer. This is not darkness. It is absence, not a void, but a pause in experience. This is where deep sleep begins, and while awareness rests, the brain continues working quietly, carrying forward everything it has learned across evolution. The story moves on from here into the deepest layers of rest, where nothing is felt and everything is restored. In this deepest layer of rest, there is nothing to notice. No thoughts arrive. No images form. No sense of time passes. This absence is not emptiness. It is suspension. The brain has entered a state it has protected carefully throughout evolution, a state where experience pauses so that repair can take place. In deep sleep, awareness is no longer organizing reality. It has stepped aside completely. This allows processes that cannot happen during waking life to begin. Neural activity slows into broad, steady rhythms, not because the brain is inactive, but because it is synchronized. Large populations of neurons begin to move together. Waves of activity travel slowly across the brain. These waves are not carrying information outward. They are coordinating internal maintenance. Connections that were heavily used during the day are reinforced. Connections that are no longer needed are weakened. This pruning is gentle, selective, necessary. Without it, the brain would become crowded with noise. Memory does not disappear here. It reorganizes. What mattered is preserved. What was incidental fades. This process happens without awareness because awareness would interfere. Conscious thought is narrow. Repair requires breadth. Deep sleep gives the brain that breadth. At the same time, the body enters its own restorative mode. Muscle tone is low. Energy is redirected. Tissue repair accelerates. Hormones that support growth and recovery are released. These processes evolve to happen together. The brain and body learned that the safest time for deep repair was when awareness was offline. This reduced risk. An organism deeply engaged with the world cannot fully turn inward. An organism deeply asleep can. That trade-off was worth protecting. This is why deep sleep is guarded so carefully. The brain does not enter it lightly. It waits until conditions feel stable. When it does enter, it stays only as long as it can. Deep sleep is fragile by design. If the environment changes suddenly, the brain can pull itself back toward lighter states. This flexibility has always mattered. In deep sleep, memory of experience stops forming. If you wake from this state, you may feel disoriented, not because something went wrong, but because awareness was not present to track time. The brain was elsewhere. It was repairing itself. This state has existed long before dreams, long before identity, long before thought. Even creatures without complex minds enter versions of this rest. It is one of the oldest gifts evolution shaped. Deep sleep does not ask questions. It does not reflect. It does not imagine. It restores. This restoration is not dramatic. It does not announce itself. You only feel it afterward, in the quiet clarity of morning, in the softness of emotion, in the steadiness of attention. When deep sleep is missing, these things feel strained. The brain carries more noise. Emotion feels sharper. The body feels heavier. This is not because deep sleep failed. It is because it was postponed. The brain will always look for another opportunity. It may arrive later in the night, or during the next one. Deep sleep is patient. It does not demand consistency. It waits for permission. Permission comes from safety, stillness, and predictability. When those signals align, the brain descends again. And while awareness rests, the systems that have carried life forward for millions of years quietly do their work. The story does not stop here. After deep sleep, awareness will return. Dreaming will reappear. The night will cycle again. This rhythm is ancient, but for now, there is nothing to follow. Only the quiet certainty that even when experience pauses, the brain continues its long, careful work. After this deepest pause, the brain does not remain still forever. Gradually, without intention, activity begins to change again. The slow, wide rhythms of deep sleep loosen their hold. Neural activity becomes less synchronized. Smaller patterns begin to move independently. Awareness does not return all at once. It reappears in fragments. This is where dreaming quietly returns. Unlike the drifting images before deep sleep, these dreams are more structured. Scenes form. Movement returns. Emotion becomes present again, but the body remains still. This separation is deliberate. The brain has learned that it can explore experience internally without risking movement in the outside world. During this phase, memory and emotion meet again. Experiences from the day resurface, but they are altered. Details blur, timelines shift. Meaning becomes more important than accuracy. This is not confusion. It is refinement. The brain is deciding what to carry forward. What matters is strengthened. What does not fades quietly. Dreams often feel vivid because emotional systems are active. Logic feels weaker because planning systems remain offline. This imbalance is intentional. Emotion needs to be processed without judgment. Memory needs to be integrated without analysis. Dreaming provides that space. This cycle between deep sleep and dreaming repeats through the night, not in perfect rhythm, but in waves. Early in the night, deep sleep dominates. Later, dreaming becomes longer. This pattern reflects priorities. Repair first, integration later. The brain learned this order long ago. By morning, most deep repair is complete. The brain turns its attention toward preparing for the day. Dreaming helps adjust emotional tone. It softens what needs softening. It reinforces what matters. This is why waking from a dream can feel emotionally charged. The brain is transitioning back to waking priorities. Awareness returns gradually. First, the sense of body, then the sense of place, then the sense of self. Thoughts regain structure. Time returns. The brain does not rush this. It checks the environment. It listens. It prepares. This preparation is the mirror of falling asleep. Just as awareness thinned carefully at night, it thickens carefully in the morning. Evolution shaped both transitions. Neither is meant to be abrupt. When waking feels sudden, it is often because the environment demanded it. Alarms, noise, urgency. The brain adapts, but it prefers gentler signals. This entire nightly cycle from awareness thinning to deep absence to dreaming to waking preparation is one continuous process, not separate stages, but a flowing rhythm. The brain does not think in terms of stages. It responds to balance. How much repair is needed? How much integration remains? How safe the environment feels? These calculations happen quietly. Every night, the brain replays an ancient pattern, one shaped by survival, refined by emotion, and carried forward by meaning. As this story continues, we will bring all of these layers together. Why understanding sleep often helps more than controlling it. Why rest cannot be forced. and why the brain, when trusted, still knows how to find its way through the night. For now, the rhythm continues. Awareness comes and goes. The night moves forward, and the brain follows the path it has always known. As the night continues its quiet cycles, something becomes clear when you step back and look at the whole pattern. The brain has never slept the same way twice, but it has always slept for the same reasons. Across evolution, sleep was never about shutting down. It was about balance. Balance between action and repair, between attention and release, between holding the world in mind and letting it go. This is why sleep still adapts to circumstances so precisely. When the day is demanding, sleep responds. When emotion is heavy, sleep adjusts. When the environment feels uncertain, sleep stays lighter. The brain is not aiming for a fixed ideal. It is aiming for adequacy. Enough repair to continue. Enough integration to remain stable. Enough rest to meet what comes next. This is why comparisons often distort our understanding of sleep. There is no universal night, no perfect duration, no single depth that defines success. The brain evaluates need, not metrics. Some nights, the body needs repair more than memory processing. Deep sleep dominates. Other nights, emotion needs attention. Dreaming becomes longer. Other nights still, vigilance remains high. Sleep stays light, but awareness rests intermittently. Each of these patterns is functional. The problem arises when expectation replaces listening. Modern thinking often treats sleep as a task to complete, a box to check, a target to hit. But the brain does not work that way. It works through signals. Is the environment predictable? Is there unresolved demand? Is attention still required? When those signals change, sleep changes with them. This adaptability kept organisms alive. Rigid sleep would not have survived evolution. The same adaptability is still active in you. When you notice variation in sleep, you are noticing responsiveness, not failure. This understanding softens something important. It removes the sense that sleep is fragile. Sleep is resilient. It has survived ice ages, migrations, hunger, danger, and uncertainty. It is not easily broken by a single night. What often disrupts sleep most is fear about sleep itself. Fear reactivates vigilance. Vigilance lightens rest. This loop is understandable. The brain senses concern and responds by staying alert. Understanding breaks the loop. When the brain recognizes that nothing is being demanded of it, it releases control. This release is not forced. It is granted. Sleep is not something you enter. It is something that arrives when resistance fades. Resistance does not always look like tension. Sometimes it looks like monitoring, checking whether sleep is happening, tracking time, evaluating depth. These actions signal uncertainty. The brain responds by staying partially awake. Letting go of evaluation often allows sleep to deepen, not because you tried harder, but because you stopped signaling doubt. Evolution did not prepare the brain to sleep under observation. It prepared it to sleep under safety. Safety is communicated through consistency, not effort. Familiar sequences, gentle transitions, predictable endings. These cues reassure ancient systems. As the brain recognizes them, it does what it has always done. It shifts responsibility inward. This is why sleep often comes unexpectedly after a period of waiting. The brain was never blocked. It was waiting for clarity. When clarity arrived, it moved. This movement is quiet. There is no moment you can point to and say, "This is where sleep began." That ambiguity is intentional. A sharp boundary would be dangerous. A gradual fade allows flexibility. This design has protected life for millions of years, and it is still protecting you now. As the story continues toward its final sections, everything begins to fold together. Evolution, biology, experience, they all point to the same truth. Sleep is not a performance, it is a relationship. A relationship between the brain and its environment, between past and present, between safety and letting go. When that relationship is respected, sleep finds its way naturally, and the brain, ancient and patient, continues its work through the night, just as it always has. Deep within the night, there is a state the brain protects more than any other. A state without story, without image, without awareness. This is not emptiness. It is restoration. In this part of the night, the brain is doing work that cannot happen anywhere else. Neurons slow their individual chatter and begin moving together like a wide, steady tide. These slow rhythms are not random. They create windows where cells rest, where resources are redistributed, where balance is restored. One of the most important things that happens here is clearing. Throughout the day, the brain works constantly. Thoughts fire, memories activate, emotions surge. All of this activity produces byproducts, tiny chemical traces that build up between cells. During waking life, these byproducts cannot be fully removed. The brain is too busy. Deep sleep creates space. As neural activity synchronizes, channels open. Fluid begins to move more freely through brain tissue. Waste is carried away. This process is quiet, invisible, essential. Without it, the brain feels heavy, foggy, less precise. This is not metaphor. It is maintenance. Evolution shaped this system carefully. A brain that could clean itself during rest could think more clearly during waking life. Over time, this cleaning became tied to the deepest states of sleep. The brain learned that awareness had to be absent for this work to proceed efficiently. Consciousness creates noise. Noise interferes with repair, so awareness steps aside. This is why deep sleep feels like nothing. Nothing is not absence. It is protection. The brain is shielding itself from interruption. At the same time, the body is deeply engaged. Hormones that support repair circulate. Tissue regeneration accelerates. The immune system recalibrates. These systems evolve to operate together. The brain and body learned that the safest time for deep repair was when the organism was still and disengaged. This required trust. Trust that the environment would not demand immediate response. Trust that the night would remain predictable. That trust is never complete. The brain keeps a thread of readiness even here, but it is minimal, just enough. This balance allowed deep sleep to evolve without sacrificing survival. In this state, memory formation pauses. If you wake suddenly from deep sleep, the moment before waking is not remembered. There was no awareness to record it. This is why time disappears. Hours can pass without sensation. This absence often feels unsettling when described, but it is one of the most peaceful states the brain enters. No demand, no effort, no interpretation, just restoration. This state has existed longer than dreaming, longer than emotion, longer than identity. Even simple organisms enter versions of it. It is one of the oldest rhythms life learned. As the night progresses, the brain does not remain here continuously. It moves in and out. Deep sleep arrives, then releases, then returns. Each return does more work. Each release prepares the brain for the next phase. This rhythm continues until repair is sufficient. Only then does the balance shift. As dawn approaches, deep sleep becomes shorter. Dreaming becomes longer. The brain senses that the environment will soon change. Light will return. Activity will resume. Preparation begins quietly. But even as that preparation approaches, deep sleep remains important. It finishes what it needs to finish. This is why early sleep often feels heavier. Why waking in the middle of the night can feel disorienting. The brain was fully engaged elsewhere. It does not like being interrupted here, not because it is fragile, but because it is busy. Understanding this changes how we relate to the night. Deep sleep is not something to chase. It is something to allow. The brain enters it when conditions feel stable enough and when repair is needed. Both must be true. If either is missing, the brain waits. This waiting is not delay. It is discernment. The brain knows what it needs. As this part of the story settles, it leaves behind a quiet reassurance. Even when nothing is felt, something important is happening. Even when awareness disappears, the brain is deeply at work. And when it finishes, it will gently return you to lighter states, to dreaming, to morning. The night continues its ancient rhythm, and the brain follows it carefully, as it always has. As the night moves forward from this deepest work, something becomes easier to see when the whole story is held together. The brain has not changed its reasons for sleeping. It has only changed its surroundings. Even now, with electric light and constant information, the brain is still following rules written long before cities existed. Those rules are simple. Rest when the world becomes predictable. Repair when awareness is not required. Return when conditions change. Everything else is variation. This is why the brain still sleeps in cycles, why deep sleep comes first, why dreaming follows, why waking emerges gradually. These patterns were not designed for convenience. They were shaped by survival, and because they worked so well, they remain. Modern humans often expect sleep to be uniform, the same every night, the same depth, the same length. But the brain never evolved for uniformity. It evolved for responsiveness. Some days require more repair. Some days require more emotional processing. Some days require vigilance to linger. Sleep adapts accordingly. This adaptability is often mistaken for inconsistency, but it is intelligence. The brain evaluates what the day demanded, what the environment allows, and what the body needs. Then it shapes the night. This shaping happens without awareness. There is no decision-making voice, only adjustment. This is why trying to manage sleep with rules alone often fails. Rules are rigid. Sleep is fluid. The brain does not respond to instructions. It responds to conditions. When conditions resemble what it evolved to expect, sleep unfolds naturally. When conditions conflict, sleep adjusts. This adjustment can feel frustrating, especially when expectations are high. But understanding the logic beneath it changes the experience. Sleep is not withholding itself. It is responding. The brain does not ask whether you want to sleep. It asks whether the environment is settled enough for awareness to step aside. That question is ancient. It has been asked in forests, on plains, near firelight, inside shelters, and now, in bedrooms filled with subtle signals. The question has not changed. Only the answers have become more complex. Modern life often provides mixed answers. Darkness, but activity. Stillness, but information. Quiet, but anticipation. The brain receives all of these signals and does its best to interpret them. When interpretation is difficult, sleep becomes lighter. not as punishment. As protection, this reframing matters. Light sleep is not wasted time, it is adaptive rest. Dreaming is not distraction, it is integration. Deep sleep is not absence, it is restoration. Each layer has a role. The brain moves between them as needed. Some nights emphasize one, some nights emphasize another. Across a week, a month, a season, balance emerges. This is why short-term sleep concern often resolves on its own when pressure is removed. The brain self-corrects. It has always done so. Evolution favored systems that could recover from disruption. Sleep is one of those systems. Even after nights of disruption, the brain looks for opportunities to repair. It may shift cycles. It may deepen later. It may compensate subtly. This resilience is built in. Fear about sleep often interrupts this resilience. Fear signals danger. Danger signals vigilance. Understanding removes fear. When the brain recognizes that sleep is not under threat, it relaxes. Relaxation allows adaptation to complete. This is why learning about sleep often improves it, even without changing habits. Knowledge reduces uncertainty. Reduced uncertainty reduces vigilance. This is not placebo, it is biology. The brain listens constantly. When it hears calm consistency, it responds with rest. As this part of the story settles, it brings a quiet reassurance. The way your brain sleeps tonight is not separate from the way it has always slept. It is the same system, operating under new conditions. It has not forgotten its purpose. It has not lost its skill. It is still doing what it evolved to do. Balancing, repairing, preparing. The night continues, and the brain continues its careful work, guided by patterns far older than worry, far older than effort. And as this long story moves toward its final chapters, everything begins to point to the same gentle conclusion. Sleep has never been fragile. It has always been patient. As the story moves closer to the present moment, it reaches a place many people recognize immediately. Difficulty sleeping. Not as a medical label, not as a problem to solve, but as an experience the brain has always been capable of. Across history, there were nights when sleep stayed light, nights when awareness returned often, nights when rest came in fragments. These nights were not considered failures. They were responses. The brain has never promised perfect sleep. It has promised adaptive sleep. When modern humans talk about insomnia, they often describe a struggle. A sense that sleep is being withheld, that the brain is refusing to cooperate. But from the brain's perspective, something else is happening. It is staying ready. Readiness does not always look like fear. Sometimes it looks like alertness without anxiety. Sometimes it looks like thoughts appearing when the body rests. The brain does not distinguish between physical threat and unresolved demand. Both signal uncertainty. Uncertainty keeps awareness active. This is not stubbornness. It is inheritance. The same systems that once listened for predators now listen for unresolved signals. A conversation that ended without closure. A responsibility that feels unfinished. An environment that feels unpredictable. The brain responds by keeping awareness closer to the surface. This response is often misinterpreted. Wakefulness is seen as malfunction. Thought is seen as interference. But thought at night is often a sign that the brain is still orienting. It is checking whether it can safely let go. When we react to this with frustration, we add another signal. Concern. Concern tells the brain something matters. Something matters means attention is required. The loop tightens. This is how difficulty sleeping becomes self-reinforcing, not because sleep is broken, but because vigilance is sustained. Understanding this changes the frame completely. Sleep difficulty is not a lack of ability, it is a surplus of readiness. The brain is doing exactly what it evolved to do when signals are mixed. Trying to force sleep often makes this worse. Force implies urgency. Urgency implies threat. The brain responds by staying alert. This is why advice that focuses on trying harder often backfires. The brain does not rest on command. It rests when it senses permission. Permission is communicated through consistency, not effort. When the night unfolds in a predictable way, the brain relaxes its grip. When expectations soften, vigilance eases. This is why many people sleep better when they stop trying to sleep, not because they gave up, but because they stopped signaling uncertainty. The brain noticed. Evolution prepared the brain to sleep when conditions felt right, not when instructed. It learned to wait patiently. Waiting is not failure, it is assessment. Some nights, assessment takes longer. The brain gathers information, listens, adjusts. Eventually, when nothing demands response, it releases awareness. This release can happen suddenly, one moment awake, the next asleep. This suddenness often surprises people. It feels like sleep arrived without effort. That is because effort was no longer present. The brain moved on its own. Reframing sleep difficulty this way removes something heavy. Blame. There is no broken system to fix. There is no personal flaw. There is only a brain doing its job in a complex environment. When that job is understood, the struggle often softens. Softening reduces vigilance. Reduced vigilance allows sleep. This is not a trick. It is alignment. As this part of the story settles, it offers a gentler perspective. Difficulty sleeping is not an enemy. It is a signal that the brain is still listening. When the listening no longer feels necessary, sleep follows. The night does not need to be perfect. It only needs to feel safe enough. And safety, for the brain, has always been about predictability, not control. The story continues toward its final reflections, where everything comes together quietly, without demand, just as sleep itself always has. As this understanding settles in, something else becomes possible. Trust. Not the kind of trust that is forced or decided, but the kind that grows when struggle fades. The brain does not respond to reassurance alone. It responds to patterns that repeat without consequence. When nights pass and nothing goes wrong, when wakefulness arrives and is met without urgency, the brain updates its expectations. It learns that staying awake is not dangerous, and because it is not dangerous, it no longer needs to stay alert. This is one of the quiet paradoxes of sleep. The more permission the brain is given to be awake, the easier it becomes for sleep to arrive. Permission removes pressure. Pressure sustains vigilance. Trust grows when the brain realizes that awareness itself is not a threat. For most of human history, wakefulness at night had meaning. It signaled danger, responsibility, or opportunity. Modern wakefulness often has none of these. It is simply awareness without demand. The brain must learn this distinction. Learning happens through experience, not argument. Each night where wakefulness is allowed to exist without urgency or correction becomes evidence, evidence that nothing needs to be done. Over time, this evidence accumulates. The brain begins to release control sooner, not because it was told to, but because it has learned it can. This learning is slow, deliberately slow. Evolution favors caution. the brain does not abandon vigilance quickly. It waits until it is sure. This patience can feel frustrating, but it is also what makes rest durable. Once the brain trusts that the night is not a problem, sleep becomes less fragile. It may still vary. It may still change shape, but it no longer feels contested. Trust also changes how the brain relates to thought. Thoughts at night stop feeling like obstacles. They become background. When thoughts are allowed to pass without engagement, they lose momentum. Not because they are suppressed, but because they are not needed. The brain stops feeding them. This is another ancient pattern. During the transition into sleep, the brain does not eliminate thought. It deprioritizes it. Thought fades because attention fades. Attention fades because nothing demands it. Trying to manage thought keeps attention active. Allowing thought to exist lets attention loosen. This is not detachment. It is reallocation. The brain shifts resources inward. As trust grows, this shift happens earlier and more smoothly. The night feels less like a test and more like a passage. This passage does not require participation. It unfolds. The brain has crossed it countless times before. Trust also reframes the body. Physical sensations that once felt disruptive become neutral. Restlessness becomes movement that settles. Stillness becomes something that arrives naturally. The brain stops monitoring the body for signs of success. Monitoring implies evaluation. Evaluation implies uncertainty. Trust removes both. When the brain is no longer checking, sleep deepens on its own. This does not mean sleep becomes perfect. It means it becomes sufficient. Evolution never aimed for perfection. It aimed for enough. Enough rest to repair. Enough integration to stabilize. Enough readiness to respond when needed. Trust allows the brain to find this balance without interference. This is why letting go is not a technique. It is an outcome. It arises when understanding replaces struggle. As this part of the story settles, it offers something simple. You do not have to help the brain sleep. You only have to stop convincing it that sleep is urgent. The brain already knows how to rest. It has always known. When urgency fades, when evaluation softens, when the night is allowed to be as it is, the brain does what it has done for millions of years. It releases, and sleep, quiet and unannounced, finds its way in. The story moves now toward its final chapter. Not toward instruction, but toward closure. A closing that does not demand attention, only presence, just as the night itself always has. As the night carries everything toward its quiet end, the story no longer needs to move forward. It has already arrived. From the first rhythms of life responding to light and dark, through vigilance, emotion, memory, identity, through deep absence and gentle return, the same pattern has repeated. Let go when it is safe. Return when it is needed. The brain did not learn sleep as a technique. It learned it as a relationship with the world. A relationship shaped by rhythm, by predictability, by trust built over time. Every layer of the brain still participates in this relationship. The oldest systems listen for stability. The newer systems release control when stability is found. And the mind, which often believes it must do something, eventually realizes it does not. Sleep was never meant to be achieved. It was meant to happen. This is why it slips in quietly, without announcement, often when attention has wandered elsewhere. This is why nights vary, why some feel deep and empty, why others feel light and drifting, why some carry images and emotion, and others pass without memory. The brain is not inconsistent. It is responsive. It is doing what it has always done, adjusting to what the day required and what the night allows. Nothing about this process is personal. Nothing about it is a test. There is no right way to sleep. There is only the way the brain moves when it is allowed to. This understanding does not force rest. It removes interference. And when interference fades, the brain's ancient knowledge becomes visible again. It knows when to slow. It knows when to deepen. It knows when to return. You do not need to supervise this. The night does not require effort. It requires permission. Permission is given quietly, through consistency, through gentleness, through letting the night be what it is. As this story settles into silence, there is nothing left to hold. No lesson to remember. No conclusion to reach. The brain has already taken over the work. Whether awareness remains for a while longer or drifts away unnoticed, the same process continues. The same rhythm that guided the first living things still guides you now. Patient, adaptive, unhurried. And as the night continues, the brain follows that rhythm just as it always has, without instruction, without force, without needing anything more. The story ends here. The night does not.